some properties of angles and specific types of angles. Before we do that, let's talk about a few things that have to do with terminology and making sure we understand what everything is. The first one is a ray. A ray has one endpoint and extends in forever in one direction. Okay, rays are named with their endpoint first and then a point in the direction of the ray second. So take a look at this picture I have here. We have A as the endpoint, and then notice that the ray continues forever to the right in the direction of B. So in order to name this one, we could call this one ray AB, and they usually use a symbol like a ray above it. The reason that rays are important is because two rays can form, an angle. Take a look at the picture I have down below. We have two different rays. We have ray AB and we have ray AC forming an angle when we have that common endpoint, which is called a vertex. Okay, so when we have two rays that share that endpoint, that's called the vertex of the angle. Let's talk about naming angles because that's important too. Whenever we're looking at figures, we have to know what they're talking about when they name an angle or tell us a certain measure. Usually, if it's an angle by itself, say this one's out here by itself, we only have one angle that we're looking at. We could call this angle A. The vertex is very important because the vertex, either you just use the vertex or the vertex has to go in the middle of 3 points in order to name the angle. So we could also call this angle BAC. Again, vertex is in the middle, or angle CAB, vertex in the middle. It becomes very important to be able to name these with 3 letters when we have multiple angles in one figure, because a lot of times they may be giving us some information or asking us to find some information, and we have to make sure we know which angle they're talking about. Remember, the vertex is always in the middle. All right, let's talk about some types of angles. We have an acute angle, which is less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is greater than 90 degrees, but less than 180, so it's in between 90 and 180. And then a straight angle is actually forms a line, is exactly 180 degrees. So down here below, we are going to take a look at some different angles. We're going to classify them. This first one would be acute. Second one, obtuse. Third one would be right. Next row, this one would be acute. Our next one would be a straight angle. And then last one is another acute. Okay. If they ever ask you to classify, they're just asking what type it is. Another term is an angle bisector. Okay, the word bisect means cut in half. So if we have an angle bisector, it's a ray that cuts an angle into 2 different equal angles. Okay, a new word here that we may not have used very much is congruent. Congruent means equal. Okay, congruent means same measure. Okay, in this case, we're talking about angle measure. So a ray cuts an angle in half and forms 2 adjacent, so they have the same one side in common. One of their rays for their sides is in common. Take a look at this one drawn here. We started out with angle CAD, and then ray AB cuts it in half. So we have 2 smaller congruent angles. These can be useful when we're solving problems. Either they'll give us an angle measure, maybe they'll give us an equation, and we have to solve for different pieces. So take a look at this one. Measure of angle, well, I need to preempt. Each angle is bisected, so each angle is cut in half, and then the bisected angles are marked as angle 1 and angle 2, okay, in each of these figures. Now, for part A, measure of angle HFG is 30 degrees. Find the measure of angle 1. Okay, so let's take a look. HFG, think about following that around. HFG is that outside angle, the bigger angle that was cut in half. So if the bigger angle is 30, and we want the measure of angle 1, which is one of the 2 that's cut in half, the measure of angle 1 should be 15 degrees, should be half of it. Second one here is more what I was talking about when I said that you might have some equations. Part B says find x if the measure of angle 1 is 6x minus 1 and measure of angle RTS is 10x plus 4. Let's take a look at what we're talking about. Measure of angle 1 we know is one of the bisected angles, okay? And that one's equal to 6x minus 1, excuse me. Then they told us measure of angle RTS. RTS, if we follow that around, the vertex is at T. RTS is the larger angle, the angle that was cut in half. Okay, so here's what I would do, and I think it makes it a little bit easier to see how to set up your equation. Let's talk about the relationship between the measure of angle 1 and measure of angle RTS. How do they relate to each other? Well, we know that the measure of angle 1, it's one of the smaller bisected ones. It should be half the measure of angle RTS, right? Because it's cut in half. So now let's plug in what we know. Measure of angle 1 is 6x minus 1. And that should be equal to 1/2 times the measure of angle RTS, which we said is 10x plus 4. Let's distribute that 1/2. Let's keep the left side the same, 6x minus 1. Now, if we distribute that 1/2, we have 5x plus 2. Now we just have linear equation to solve. Let's subtract 5x from both sides, so that would leave 1x or x minus 1 equals 2. Now let's add the 1 over. So x equals 3. And again, I would always check what they're asking us to find. They wanted us to find x in this case, but they very well could have said find the measure of an angle. If they had said find the measure of angle 1, we would not only have to find x, we would then have to plug back in. 6 times 3 minus 1, 18 minus 1 gives us 17 degrees. And let's just check that it makes sense. This should be half. Oh, I don't know what happened there. This should be half of the measure of angle RTS. So if we plug in 3, 10 times 3 is 30, plus 4 is 34 degrees. And we can see that that does work. 17 is half of 34. So you can always plug back in and check and make sure that your answer makes sense. All right, now let's talk about some other special angles. The first is a linear pair, which is a pair of adjacent angles, so they have a side in common, whose non-common sides form a straight line. Okay, so the big thing here is we have a linear pair, they form a line, two angles that form a line. And as we already know, a line, which is like a straight angle, forms 180 degrees. Okay, so angles 1 and 2 in this picture here are linear pairs. They form a line. Then we have two terminology things. We may have already heard of these before. Complementary angles are angles whose sum is 90 degrees, so they add up to equal 90. Supplementary angles are angles whose sum is 180, so they add up to equal 180. So guess what? Linear pairs are supplementary, okay, because they add up to equal 180. Now, down below, another type of special angle pair is called vertical angles. Okay, vertical angles are two non-adjacent angles formed by two intersecting lines. Okay, a lot of times we think of these, an easier way is maybe to think of these as a mirror image, okay, because they are reflected. They should be equal in measure, okay? They are congruent, okay? So take a look at this picture. Angles 1 and angles 3 are vertical angles. Notice they look like they're mirrored, okay? And angles 2 and 4 are vertical angles. Now, let's also talk about linear pairs. We have some linear pairs here. Angle 1 and angle 2 are a linear pair, okay? Angle 2 and angle 3 are a linear pair. Angle 3 and angle 4 are a linear pair, and angle 4 and angle 1 are a linear pair. Okay, so we have a lot of things going on, even with just 4 angles. We have 2 sets of vertical angles and we have 4 sets of linear pairs. So there's a lot that can happen with a problem like this, where they may want us to solve for angle measures, or they may have equations like we saw before with the bisectors. Let's take a look at some of those. All right, let's take a look here. First of all, we want to solve for x. Let's take a look. What kind of angles do we have here? Notice that this angle x and 63 would add up to equal 180. That's a linear pair. Okay, so we know x plus 63 should equal 180. So all we have to do is take that from 180. If we subtract 63 from 180, we should get 117 degrees. Take a look at part B. Part B, we have another linear pair. 103 degrees and k degrees should add up to a total. Again, this is a linear pair. I'll make sure to write it for us. Okay, so we should have a total of 180 degrees if we add these up. So all we have to do is take 103 from 180, which would leave us with 77 degrees. Okay. Now we're getting a little bit more complicated with the next ones because it's not just a variable for the angle. We now have something added or subtracted to it. Take a look at C. Okay, we want to find the value of W. Take a look at the two angles that we have. Those look like the mirror images, right? These are vertical angles. So that means that they are congruent to each other. So we can set 105 equal to W minus 10. Then in order to solve for W, we would just add 10 to each side. So W is 115. Next, take a look at letter D. We have an angle of 95 degrees and we have an angle of D plus 13 degrees. What's the relationship here? Notice that these two form a line, so this is another linear pair. Our property here is that they are supplementary. They add up to equal 180. So 95 plus D plus 13 should equal 180. If we combine, oops, oh boy, that's my whole thing there. If we combined 95 plus 13, that gives us 108. Now, if we subtract 108 from 180, that leaves 72 for D. Okay, so again, we are solving some equations here sometimes, especially where we're adding or subtracting something. But the big thing that we have to realize is that the reason we are doing so is because whether the property is that they are congruent, they're equal to each other, or they're adding together to equal 180, depending on what type of special angle pair we have. So knowing, first of all, what types of angles they are they vertical, are they a linear pair, and also knowing the property. If they're vertical, they are congruent. If they're a linear pair, then they add up to equal 180. Let's try a couple more where we do a little bit extra. We're going to solve for a variable, and then we're also going to plug back in. Okay, so let's take a look at this first one. We want to find the value of x, and then we want to plug it back in and find the measure of angle MAT. So let's take a look. We can see that these two angles form a linear pair. Okay, so it might be good to just kind of note that this is a linear pair. And we know that linear pairs add up to equal 180. They are supplementary. So we can say that 7x minus 14 plus 2x plus 5 should equal 180. Let's combine our like terms over here on the left. 7x plus 2x gives us 9x. Negative 14 plus 5 is negative 9. And that's equal to 180 still on the right side. Let's add 9 over. So 9x equals 189. If we divide by 9, then that's going to give us 21. So we've solved for x now. We know that x is 21. Now it also wants us to find the measure of angle MAT. Notice that MAT was 7x minus 14. So we need to plug back in. We need to do 7 times 21 and subtract 14 from that. Okay, 7 times 21 would be 147 minus 14 would give us 133 degrees. Okay, so notice on that one, we had to do two pieces. We had to solve for the variable, and then we also had to plug it back in. Now let's look at this next one. We're going to have to do the same thing. We're going to solve for the variable, and then we're going to have to plug some stuff back in and find some angle measures. So let's take a look here. These angles, they look like mirror images, right? They are formed by the same lines. These are vertical angles. So we know that they are congruent. So we could set 4x plus 24 equal to 7x plus 3. Now we want to solve for x. So let's subtract 4x from both sides. That leaves 24 equals 3x plus 3. Subtract the 3 over. 21 equals the x. Divide by 3. And now we know that x is equal to 7. So we solved the first part. Okay. Next, let's take a look at what they want us to find. The first angle they want us to find the measure of is angle PIR. Okay. Angle PIR is here, and that was 4x plus 24. Now we want to plug in 7 to that. So 4 times 7 plus 24. 4 times 7 is 28 plus 24 would give us 52 degrees for angle PIR. Now, notice they want us to find angle RIM. That's not one of the ones we had an equation for. So let's think about the relationships here. We just found PIR. Take a look. PIR and RIM form a line. So those are a linear pair. We know linear pairs should add up to 180. So if, write this out, okay, if we want to get the measure of angle RIM, we should be able to take 180 and subtract the measure of angle PIR. So we just need to do 180 minus 52. We just found that 52. So if we subtract 52 from 180, that leaves 128 degrees for measure of angle RIM. Okay. We're going to go through a lot of practice with these types of angle pairs. So please feel free to reach out to me if you have questions. Hopefully this was a good overview of your different types of angle pairs that we're working with today.